Hello everyone and welcome to the 10th electronics tutorial. In this tutorial we will look at how we can build a circuit to divide voltage and current. In tutorial 3 we discussed resistors in parallel and in series. The type of circuits we used demonstrated how voltage and current is affected by resistance and how we calculate totals for volts, amps and ohms. But resistors in parallel and series do not show any practical usage. So in this tutorial we will use resistors in parallel and series to create a current and voltage divider, and then cover the formula needed to calculate their outputs. With this knowledge you will be able to recognise why the components are configured in this formation when studying a schematic. Let's firstly look at a voltage divider. This circuit uses two 500 ohm resistors in series and a 9 volt power supply. Between the two resistors we have placed a voltmeter so we can read the output. When we play the simulation we can see the voltage output is 4.5 volts. Using two resistors of the same value divides the voltage equally. Adjusting either the first or second resistor affects the amount of voltage at the output point. Let's look at the equation used to calculate this. The equation is as follows: voltage supply multiplied by resistor 2 divided by resistor 1 plus resistor 2. So our equation looks like this: 9 volts multiplied by 500 ohms divided by 500 ohms plus 500 ohms. We need to simplify the equation to get the final answer. We first add R1 and R2 to give us 1000 ohms. 9 volts multiplied by 500 ohms divided by 1000 ohms. To simplify further, we divide R2 by the total of R1 and R2. So we divide 500 ohms by 1000 ohms, which equals 0.5. The simplified equation is now 9 volts multiplied by 0.5, which equals 4.5 volts. Let's adjust the value of R1 to 600 ohms and run through the equation again. 9 volts multiplied by 500 ohms divided by 600 ohms plus 500 ohms. Simplified to 9 volts multiplied by 500 ohms divided by 1100 ohms. Now the equation is simplified to 9 volts multiplied by 0.4545, which gives us a voltage output of 4.09 volts. The current divider circuit uses two parallel resistors. This circuit also uses two 500 ohm resistors and a 10 milliamp power supply. Two ampermeters have been placed on each branch of the circuit to view the output. When we play the simulation, notice that the current has divided equally over the resistors and both are drawing 5 milliamps. Again, if we adjust either resistor, the amount of current drawn changes. Let's look at the equation for the current divider. So the equation we use looks like this. Current total multiplied by R2 divided by R1 plus R2. So this works out to 0.01 multiplied by 500 divided by 500 plus 500. So let's simplify it again. 0.1 multiplied by 500 divided by 1000. 500 divided by 1000 equals 0.5. 0.01 multiplied by 0.5 equals 0.005 or 5 milliamps. Let's change the value of R1 to 400 ohms. 0.01 amps multiplied by 500 ohms divided by 400 ohms plus 500 ohms. This simplifies to 0.01 amps multiplied by 500 ohms divided by 900 ohms. Simplified again to 0.01 amps multiplied by 0.556 equals 0.0056 or 5.56 milliamps. R1 will draw 5.56 milliamps and R2 will draw the remaining 4.44 milliamps. This two-stage amplifier circuit is a good example of where a voltage and current divider is used. The first two resistors before the transistor act as a voltage divider to stabilize the bias of the transistor. The second set act in parallel with the first set to regulate the current. I hope you have enjoyed this tutorial. In the next tutorial we will build a circuit using the 555 timer integrated circuit and the components we have learned about in the previous videos. Please, as always, feel free to ask questions and leave comments. Thanks for watching.